Welcome to Integrated Math 3. On this episode, Stevenson will demonstrate
We've seen how two-dimensional shapes can be rotated to create three-dimensional shapes, which is pretty cool. So we can go from a two-dimensional figure to a three-dimensional shape, which is pretty awesome. Let's specifically focus on one of those. If we take a rectangle and rotate it on one of its sides, we create a cylinder. So with a cylinder, we have two congruent circles at the end of its bases, and then essentially we have a rectangle that's wrapped around it. Now, I want to talk about what the volume of a cylinder is. And if we think about how this shape is created, it can kind of help us with finding this formula. If you think about it, the volume of a cylinder is a bunch of circles stacked of the same exact size stacked on itself. So what we can say is we could find the area of each one of those circles. And if you remember, area of a circle is pi radius squared. So we're going to have each one of these circles is going to have the same exact radius, the area of one of those circles. But the question is, well, we're stacking a bunch of circles, correct? Well, how high are we stacking that? Or how high are we making the stack of circles? That's going to represent h. So the volume of a cylinder is the area of one circle, which can be found by its base, times by how tall the cylinder is. Now, cylinders can also be on their sides. And these can be sometimes a little bit confusing for us, because we're used to seeing cylinders like this. But don't let it confuse you. This is our radius, and then in this case, that is our height. So you can imagine the cylinders, the circles, are kind of stacked this way. Okay? So you have two orientations of your cylinder, but the formula is still the same. Let's apply the formula and figure out the volume of this cylinder. Pi is a constant, so we need to know the radius and the height. Well, the radius is 8, and the height is 24. So the volume is pi times the radius squared times the height. Now, this is my answer in exact form. So there's two ways we can write our answer. We can do it in exact form, or we can do an approximation. In this cylinder example, notice we're not given the radius here. So the cylinder is still in that upright orientation, but we're going to calculate the volume, but we're not given the radius. So we need to know what the radius is, but this is not the radius. When the line goes all the way through the center of the circle, but from one side to the other, we actually have the diameter. So let's review what we remember about circles. The radius starts at the center and goes to one side. The diameter goes all the way through, okay, through the center. So if you double the radius, you get the diameter. If you know the diameter, then you would take half of it to get the radius. So in this particular case, we know the diameter and we know the height. The height is 10 feet and the diameter is 22 feet. But if the diameter is 22 feet, that means the radius is 11 feet. Now we have everything we need to calculate our volume. Again, there's two ways you can write your answer. You can write it in exact form, which would leave pi alone, or you can approximate it, which means you take your number and you multiply it by pi.